All right, cool. Super excited for tonight. So just welcome everybody to the Aftercamp Meetup. This is like our fourth or fifth one. Uh, we actually record all these as well too. We post them on YouTube. We will definitely post this one, of course. And a couple thoughts, just real quick, if you're new with us, just some quick context and background. My name is Scott, and Rachel is joining me here, actually in the same space. She's just sitting over in the kitchen there. We run the Aftercamp Meetup, and our background is largely boot camp and also developments. So, some quick context: I've been in the development industry for about 15 years, largely broken up between enterprise, education, and agency. I'm currently the director of engineering at an agency here in Kansas City. And I run a team of about 30 engineers, cloud engineers, and architects. So why are we doing this? Really, what Aftercamp is all about is really just this idea that this continued support post graduation. So whether that be through a boot camp or that be through a CS degree, or if you're self-taught, there's a lot of good materials out there to learn about software engineering. But there is still kind of this gap, right? There's this gap that typically gets filled day one of the job if you have a good senior and you have a good team and they level you up. So really what Aftercamp is about is teaching content that really I think is not really well represented online. So far we've done a couple things, and really the other thing too is I'd say it's to the context of what we call the typical graduate from a boot camp. Engineering, coding, course reports. So really, we're teaching everything to that context. That way, people can feel if they're coming out of a boot camp or coming out of a self-taught scenario. This content is largely targeted toward you and your context. So tonight we're going to be talking about AWS for developers, but we're going to be talking about it from the context of a bootcamp grad. And so chances are good you may have touched like Amazon S3, but there's this larger picture of AWS. And what I want to do tonight is I really want to break down what AWS is, but also kind of shed some light on some of the services that you should know from AWS. So we got I'm going to break down just quick introduction to AWS. I'm going to talk a little bit about just some really basic computer ideas. One of the things I did in some of my research and interviewing people and talking to them about what, their career is that if you come from a non-traditional background, there's actually a really good chance you don't know how a computer works. And I don't mean that condescendingly. I'm just saying, like, do you know like how a computer functions? And that is actually a really big deal when it comes to AWS, because so much of that like foundational knowledge really helps you understand what AWS is actually doing. So we're going to just do some very light, basic introduction to computer stuff. And then we're going to start diving into AWS. And I got some examples. I have like 3 different examples. Rachel had to rein me in on my 4th one. It was like this crazy IoT thing. But so I got 3 really good examples about that use AWS, and they use some services that I think that if you are kind of post-graduation moving into the first year of your career, these would be really, really good ones to have a good handle on. So we are going to get all of that covered today. And then the other thing, big thing too, is next step. AWS has an amazing ecosystem of places to go learn. They have a certification path. And so I want to talk a little bit about where you can go to learn that. And I think that there's like a huge, like, I don't want to call it predatory market, but there's like a huge predatory market in the AWS education space. So like, I just want to kind of show you, hey, this is the good ones that you should go to. They're free. And then talk a bit about what that certification does for you. So kind of a hefty agenda, but I think we can cover it all in a way that's super conversational. As always, just interrupt me. Like if you have a question, like I don't get bothered by you cutting me off. I've been teaching for over a decade. This is about you. This is not about me. So don't worry about how I feel if you cut me off. Just go ahead and cut me off. All right. So with that, I'm going to go ahead and share my screen, and we're going to start diving into AWS. So let's just go ahead and share screen. Okay. So AWS, Amazon Web Services. So AWS, what it's meant for, what it's great at, is basically allowing you to kind of pick and choose what they call services to help expedite, and in some cases, like save a ton of money on development. Now, there's also this other kind of thing that we need to talk about tonight is this concept of what we consider to be traditional IT. Now, way back when I started an agency about 10 years ago, I left enterprise, I left Best Buy Corporate, and I went to a small agency called Nerdery. Was that we were servicing customers, meaning we were building applications for customers, but we actually had an actual server room, which means that when we were finished with the code would then literally go get packaged up and deployed to like what was equivalent to like just a really giant closet that had a bunch of really like these cooling elements. So our code literally was physically being served from the internet from that space, from our office. And we had an IT team that really worked to administer all of that stuff. So they handled the code transition to the server. They set up the server environments, operating systems, connections to the internet, all that jazz. So cloud, really why cloud has really started to pick up and become like this really amazing kind of product offering for the tech industry as a whole, is that stuff was really expensive. It was expensive to buy servers. It was expensive to host. It was expensive to hire IT. It was expensive to do all of this, like to have the ability to actually bring code onto the internet. And what cloud did is that it basically gave us the ability to just bypass all of that. And companies like AWS, Google, Heroku, Azure, Microsoft Azure, they created solutions for us to just take what we need, right? Because that would be the other big thing is you'd buy this big server and just need like 10% of it, right? You didn't need the whole server. Or God love you, get into Black Friday and you're some sort of retail application. You only needed 10% of the server the rest of the year, but Black Friday, man, you needed 3 servers. And so there's this idea of scalability that cloud really solved as well too. Now, some of the big players in the cloud space, I brought up 4 of them already: AWS, Microsoft Azure, Google Cloud Platform, or what they call GCP, and then Heroku. I want to talk about just them briefly here for a second. I think Heroku is an amazing tool if you're starting out or you're kind of doing like personal development. And so most of us, when we go to boot camp, we learn Heroku because it is so crazy easy to just spin up a quick server and boom, your stuff is on the internet. Which I think is totally fine. I think it's a great place to start, but you definitely graduate into one of the other platforms. You graduate into AWS, you graduate into GCP, Google Cloud Platform, you graduate into Microsoft Azure. So quick note on all these. I would say my first cloud experience was actually with Microsoft Azure. It was kind of this complex server CMS, actually mixed reality experience I was building in conjunction with 3M and Microsoft. Really cool. It was my first real taste of cloud, and I was easy it was to get everything up and running and deployed. GCP, Google Cloud Platform, actually, I have a little bit of my code out in the ether that contributes to GCP. Like I've actually written code for like Google through the agency and like got a chance to contribute to that. But I got to tell you, like AWS is where my heart is. Every time I interface with an AWS service, I get super, super excited. It's super easy. It's well documented. Got a great community. And so just can't say enough good things about my experience with AWS. I have not run into any major issues other than I screwed something up where I would turn on a service that I didn't mean to, and have an extra $5 on my bill. It's not that big of a deal though. AWS actually has a lot of free services as well too. In fact, a lot of the stuff I'm showing you tonight is all based on free. Which means that as a developer getting into it, you can actually use a lot of the services that are taught in their courses, and do so literally at no cost to learn, but also no cost to like use and deploy. So before I get into any cloud, I just want to talk briefly about computer stuff. So the reason why computer stuff comes up is just because a lot of what a second. Oh, cool. So yeah, Michael's over at AWS. So I'm happy I said all those nice things because Michael's in the crowd. Okay. So I will talk briefly about how computers work, because a lot of what AWS is going to solve for you kind of plays out this understanding of how a computer works. So I have a very simple little kind of chart here. And there's four pieces of the computer here, but 3 of them are the ones that we really care about tonight. So if you open up a desktop computer, there's going to be some sort of motherboard. And the motherboard acts kind of like the central nervous system, or like the skeleton of a body, where it holds everything together and you plug everything into the motherboard. So motherboard handles all the communications between all the different pieces, but the motherboard kind of is where the glue that holds everything together, so to speak. But there are kind of these three core pieces that we really need to focus on and understand how a computer works. The first is the processor. The second is the memory, also called the RAM. And the last piece is the hard drive. And so just at a very, very, very high level and a gross oversimplification, here's what each of these pieces do. So hard drive is like long-term storage. It holds on to all the pieces of data and it says, I'm going to like basically take your long-term memory in your brain. The processor, kind of skipping over, going from hard drive to processor, the processor is the component that does the computing. It does the processing. It does the thinking, so to speak, right? And the RAM definitely operates as an intermediary. So think about it this way. If we install an application, that application gets installed into the hard drive. But there are pieces of that application that need to, like when you turn the application on, like the processor's got to do some work. So all of that stuff is stored into memory, where like the pieces that are needed out of the hard drive essentially copied to the memory, continue to work on through the processor. And so this exchange and this dance happens between these three different pieces. So kind of expanding this idea is that your computer, you know, these pieces make up a computer. Your computer is a set of physical hardware that runs software, which I think we all intuitively understand because we're programmers are in the tech industry at some point. But next thing we kind of say is, well, what software does it run? Well, the main piece of software it typically runs is an operating system. And inside that operating system, you have separate applications. So you have things like, you know, Steam or, you know, Slack or Zoom in this case, if you're on Zoom tonight, um, or a web browser like Chrome. And so when you think about it, what's happening is when we look at the chart that we're used to seeing, this chart's the one I've been pulling up quite a bit. When we build applications, we build in the full stack, meaning that we build the front end, we build the client, we build the server, we build the database. But the question kind of becomes who or what is running each of those pieces. So once again, at a super high level, sort of what's happening here is if we just drag this out and it's going to eclipse this stuff and send it to the back. Send it back. And then we are going to copy this and paste it and just drag this in here and send this to the back. Okay. So at a very high level, we have Chrome in this case is the browser, right? The how we explore the internet. But when we build applications in JavaScript, jQuery, HTML, CSS, or using React, Angular, whatever, that front end experience is being run in the browser, right? So Chrome is actually the thing that is running those elements for us. But on top of that, what's happening is that something's running the browser, and what's running that is the operating system. So the operating system is running all of that. And then if you want to go out one more layer, there's hardware that's running that operating system, that's running that browser, that's running that front end client side experience you're programming. So here's the point. So when you're working on applications, we kind of take all this for granted, right? We don't really think about it too much as we're going through and coding things. We just know that when we you know, double click the index.html file, if you're just working on just front end, that loads up and it'll grab your JavaScript because you told it to, and everything just sort of works. And if you are hosting it on a server, you just go to like localhost 5000 or 3000 or whatever, and we've set up that server to serve back those files. But at the core, what's happening, you got to remember, is that all that stuff is happening locally, meaning that our operating system is actually running Node, that's running the server, actually running on that operating system as well too. So kind of to encapsulate all these pieces, just understanding that your applications run what we kind of just overarchingly call an environment, and that environment is running on hardware. And this is a big place of where these cloud platforms, and specifically AWS, really steps in, is that they essentially handle a lot of those kinds of considerations, right? As a developer, we're not really thinking about IT related functions, but we're starting to, right? I would say that over the past 5 or 6 years, it has become more and more on developers to understand how these pieces work and understand some of these IT functions. So a couple of roles have actually come out of this. I'm sure you've heard the DevOps role. or a cloud engineer role. And those are folks that were probably IT at one point, but are switching over to be cloud engineers or DevOps to really help, so kind of like, helping companies get into this space. So I'm going to briefly cover just what AWS is and some of this, what we call services. And we're going to kind of point to the IT related ones, but I'm going to let the AWS training explain those, because I don't think that tonight getting into all of the IT related stuff is something that you're going to be able to relate to out of the gate. I know that that's like a big barrier for a lot of people when they're getting into AWS, is understanding like, why am I learning all this stuff? Like, I'm not in IT. But it does matter, right? It will matter. And so I guess the goal of tonight and what we're trying to do is I want to show you just some of the things that AWS can do, that we have some confidence in understanding what you can do in the space, and then really where to go from here. So really quick, what AWS actually is it's a collection of services that you can use to basically streamline the development process. It sounds big and vast because it is. There is a lot of things you can do with AWS. So my dogs are playing in the background, so if you hear barking, I apologize in advance. But the one most common one, then, once again, in interviewing people and kind of prepping for this talk and trying to understand where are people at, the number one service that I see developers typically interface with is a service called S3. And what S3 is it's an individual service that AWS offers that allows us to do blob storage. It allows us to basically store bigger sets of data than our traditional like databases like MongoDB or Postgres. We can save whole files in S3. So typically when students or graduates are working on projects, they inevitably want to work with photos, and they want a way to store those photos, and S3 becomes kind of the awesome solution for that. And we're going to take a look at a solution that incorporates that here in a second. But typically S3 is the entry point for most web developers getting into AWS, or really any other cloud service. So the goal tonight is to actually just expose you to some more and get you to say like, hey, here's all the ones that I think you should be looking at as you get into more and more cloud. So before we get into that, I want to kind of summarize this introduction here and just say that what AWS gives us is the ability to quickly expedite our development process through a set of services that are really, really easy to integrate. So I got some samples tonight, but I guess before I get started and diving into any of that, are there any kind of questions we want to sneak in here just before we get out of the intro here? And while you might be typing, I just want to say, I always appreciate when you all come. I am like a big nerd for growth. One of the things I've always said about just in general, those developers who go out and choose to learn is like, if you rely on work to learn, you're going to grow in the direction that work wants you to grow in. And I think, if you really like focus in on like grow, like steering the career the direction that you want to go, you get to be in control of all that. And the thing I always say is don't leave your growth a chance. So just thank you always for coming tonight. All right, Fernando is off. Okay, cool. All right, so we're gonna dive in. I got some examples I want to show you tonight. So to get to these examples, I just want to talk through just our very basic stack. Once again, we have front end, we have a client, we have a server, and we have a database. And if you're self-taught and you're going to get things like full stack JavaScript tutorial, they're going to teach you these 4 different pieces. And so the regular players are there: HTML, CSS, JavaScript, and maybe Angular, React, depending on the course the tutorial took. Node, Express, Postgres, Postgres or MongoDB. And basically, when we say full stack, we're referring to these 4 pieces and the communication between each of these pieces. And the other week when we talked about, we were talking about system architecture, we talked a lot about just this idea. Let's see if I can get back to it here. This idea that different pieces can talk to each other. So we kind of made a crazy application, and we showed we had 5 different node servers all talking to each other. And we were basically using a very simple front end and having these different servers or services eventually all talk to each other to get to the database and go all the way back. And I use this as a scaffold to get to tonight, because if you kind of loosely understand what's going on here, you can definitely understand what AWS is all about. So let's go to this example right here. So this is the example I'm about to show you. And it is as simple of an application, I think, as I can make with our with AWS that didn't use S3. So what we're going to take a look at is a very, very simple HTML page. That's some very simple raw JavaScript. I'm not even using a library or framework. I'm literally just using plain old JavaScript, or what we call vanilla JavaScript. We have a very simple node server. And instead of using Postgres local on my machine, I'm using an individual service from AWS called RDS. So what RDS is it's a relational database solution provided to you by AWS. So let's go ahead and spin that one up real quick. I think this actually might already be up, which is great. Let's just turn it off and turn it back on again, just in case, because that's the way I roll. All right. So localhost 5,000. So localhost 5,000. Okay. So really what the application is here is that it has a very simple input and a send button. And then there is just items listed out. So in this case, Scott Bromander and Rachel Bromander. And if I want to add my son, I hit send, and it adds Jackson Bromander. Not super impressive, I get it. But let's take a look at the code and just see what's there. So the first things I want to address is how simple the application is. Literally no voodoo. It's just pulling in one script file. There is no additional libraries. This is very simply just this index.html that points to this app file. The app file itself, and I decided it's some gross, dirty JS, but I wanted to keep it sort of simple and sort of straightforward. There is a button on the screen, so we just log the button. And essentially what it does is when we want to add an item, it collects the data off the input and does a post to the server that I created, which I'll show you in a second, and it just sends the data up. And after it's done doing that, it gets the LLM input value, clears it out, and then goes to this get items. And if there's any errors, that we log this. What get items does is it goes and does a call to the server. In this case, it does a get request and says, once you are done with that get request, go ahead and update the view using the data that came back from the database, or it came back from the server. And updating the view just takes it in, takes the data in that it got from the server and puts it onto the DOM. So the key point here is that the JavaScript itself is not, while it's raw JavaScript, and I get it might be a little confusing, it really is just not using any libraries. This is what jQuery does for you if you take jQuery out, or Axios or whatever you try to use. But all it does is it can post data and it can get data, and it just writes it to the HTML page or the DOM. So looking at the app.js, this is the entirety of it. It's not super huge, but I'm going to talk about what's happening here. We have bring in Express, which is our framework. We create the app from our framework. We use PG, which is the connector between the server and the database. Now, for those of you coming from the MongoDB world, that might be Mongoose, right? So PG is the connector between our server and our database. I have some .env configuration. I'll talk about that here in just a second. We'll come back to that. This gives us the ability to serve static files, so our index and app. This allows us to use JSON and receive information off the body from the front end. There's some configuration setting stuff. What this is doing is it's an object that basically we're going to use to turn our connection on to the database. But what you're going to notice here is that these are connections set up through RDS, and we'll take a look at those variables here in just a second. So the user, password, host, port, database are all configured in the environmental file. And what you're going to see is that this is connecting actually to AWS RDS. So then we connect our connection, or we make the connection between our server and our database, log some errors in the connection. And then here, it looks just like you'd expect it to see if you're running Postgres local on your machine, right? Just regular old insert into. All of the stuff is regular old Postgres. There's nothing magic or nothing AWS related here. So let's go back up to this configuration object. So this refers to the .env. I'm going to show you this. I'm going to show you some username and password. I'm going to change it for all the folks who are probably watching the recording. That way I don't get any bots attacking this one. But the host name was provided to me by AWS. We'll take a look at it on the AWS side in a second. Username was Postgres. The password is Aftercamp Meetup. The port configuration, and then I was going to do a Lambda too in this one. I decided not to, but I called the database test RDS Lambda. So all of that stuff is used to configure. And if you were using Postgres local on your machine, you would have to do the same thing. So we just use it for RDS instead. So yeah, I mean, really, the setup is very, very similar to if you're doing anything else. So this is the setup for RDS and the code side. Let's go take a look at AWS and hop into RDS. So to get to these services, really from the main, where did it go? From the main console, and I'll talk about this here again in a second. You can type in any service, in this case RDS, and it pulls up a list. And so we just go to RDS. Everything's running a little slow tonight. It would pop up to the dashboard. Okay. So it pulls this up. And so there are, the interface is kind of intense. I will totally agree to that. But all of the tutorials that Amazon provides are super up to date. So you can actually, it'll walk you through. And so here you can say, hey, I want to create a database. And you can kind of go through those steps. And I'll leave the tutorial to cover the specific setup stats. At this part of this, or this stage of the game, I'm just trying to show you that, like, hey, it's all kind of being done through Amazon. So there's my little database. It does not show us much in terms of like a view of what's inside the database, but this is the database that I'm connecting to. Here I'm giving some information about its usage, its current activity, what engine it's using, so Postgres, MySQL, etc. And like I said, the tutorial will kind of get into the weeds with you a bit, but there it is, up and running. So what problem does this solve, I think, is a really interesting question. So here, I'm going to show you a document from another application we're going to take a peek and look at tonight. I'm going to go to Documents. And let's take a look at this one here. And actually, while I'm loading that one, let's load this one too. Nope. Okay. So an application we're going to take a look at here in a little bit is, I have a React application. There's a Node app. And typically when we deploy our Node app or to Heroku, which is the most common service I see boot camps using, we typically do this add-on thing that for Postgres, where it's an extra command. You probably barely think about it, extra 2 commands. And we say something effectively to the effect of like Heroku create, that creates the place for us to put our Node app. And then we say, hey, get push Heroku main, whatever, where the application is pushed up. So that pushes the code up, but then we need to say something to the effect of like Heroku add-ons in our command line. And we say, hey, we want to create a Postgres. So really, like, you have some experience in deploying to the cloud, even if it's not underscored. And so with this RDS, what we're able to do is essentially convert that to, deploy on AWS, our actual code. And I'll talk about that here in a second, but then deploy the RDS instance as well too. So that's what you're going to kind of see with AWS, is that basically AWS steps in and at a kind of micro level solve these little problems for us. So in this first example, it was just very simply the database solution. We're not actually deployed, but we would have to, right? So if we wanted to deploy the app to be on the internet, I would need to pick a cloud service to deploy that to. So that could be Heroku, but it could also be AWS, and AWS could handle the hosting of that application. But here's a really important piece I can kind of point that I want to illustrate, is that with AWS or any of these other cloud services, we get to pick what pieces go where. And there's some advantages that, typically if you're the architect, you're thinking about what gets deployed where. It gets a little bit deeper than that with like subnets and private and public connections and that sort of thing. But the point is, I was able to deploy this little piece to AWS, which is pretty awesome. I'm going to move on to a slightly bigger example. I'm just going to check the comments and chat here quick. Okay, cool. Awesome. All right. So I'm going to take a look. I'm going to show you a slightly bigger example here. And so I'm going to walk you through this next application. We're not going to get into the code too much. Shoot. I'm going to pull it up in here and open it. This one actually is deployed on Heroku. So there's a piece of it that's on Heroku. It is Heroku, so it's got to fire up. It's a free tier. So we'll let that work for just a second. And I want to show you the architecture graph for this one. So this one is going to use a different AWS service. So what you're going to see here in a second is that we have a Node app that serves a React application. Redis and Postgres are also deployed through Heroku, which technically are also two services. But then we also use Amazon S3 in our solution as well too. So I'm going to walk through the application quick here and kind of talk about which piece is which. So here, really quick primer on this application. What it was an application I built last year at the start of COVID. I was teaching at Prime Digital Academy, and we were figuring out how to go remote. And obviously we were in this crazy in-person experience 40 to 60 hours a week, and all of a sudden all of us were thrust into remote learning, which was crazy. And a couple weeks in, I noticed that people were getting the wear of that first couple of weeks of the pandemic. We're wearing on people. And I said, you know what? I looked at Rachel and I said, hey, let's create a way for people to get outside and still participate in the community. So we ended up building this this Prime Photo Challenge application. So it's super simple. The code's online. It's sort of broken. I need to fix it because it's a little outdated. But you log in, and when you log in, you are greeted with a list of challenges. And the idea is that you go out into the world and try to find something like a Limp Bizkit CD, and you take a picture of it, and you would submit that picture for judging, for a judge to approve it or deny it. And depending on how your team or depending on whether or not the judges approved it, you got scored. So right now, I kind of just built a scaffolded up a quick demo instance for tonight. I am both a participant and an admin, but here you can see that Team Awesome is winning because it's the only team, but they also have 6 points. And then you can see all the approved photos. The other thing that we did too is that we sent out these little cards to everyone. We hand wrote them and mailed them out, and that way you had to take a picture of these things with the photo card to prove that you're not just grabbing the image off the internet. So basically, the way it works is that you go into the world and you find something. You find a Teddy Ruxpin. You hit submit. You'd upload your image, and this is all mobile optimized. So we'd be doing this on our phone, and then we pick an image, and that loads up a loader. Could not request signing server. Womp womp. Something's up tonight. I was working literally an hour ago, so go figure. But once you submit that photo, it goes to be judged. So regular users don't have this admin page, and the judges can actually look at the photo in detail and approve or decline it. And if you're approved or declined, either says accepted or rejected. And there also is submitted as well too if the judge has not judged it yet. So a couple of things, kind of getting into the tech piece of this. When you upload a photo, what's going on here is that you're actually going to we're basically submitting and taking that photo, and I'd actually argue you take that photo and you basically upload it to AWS S3. And S3 is a service that is good for object storage. So it can be images, it can be files, it can be a lot of different things. It could just be data. It's pretty robust. It's a really, really great service, but it could save images. And so once the image is saved to S3, it sends back to the original caller. It sends the URL of where that image is in with S3. So if we take a look and let's go over to our console of AWS. I'm trying to find my bearings here. Let's go take a look at S3. We store these things in, they're called buckets. So Prime Photo Challenge. And basically images are just stored here. And I have no idea what I'm about to look at. So just buyer beware here. And here is the image stored. And sidewalk chalk art, perfect. So when Amazon actually stores this image, or S3 stores this image, it actually creates a URL for that image where that image exists on the internet. And it sends it back to the front end. And so what that gives me the ability to do is that I can send that up to my server, and I can store that into Postgres. So rather than store whole images into Postgres, we're just storing the URL to that image. So what that means is when this loads, let's say the report, it's not, it's basically what's happening in the code is that there are references to where these images are located on S3. And we set our image tag source to equal that endpoint or that destination or that URL of where that image is sitting. So probably are wondering maybe too what this Redis thing is. If you're coming from bootcamp, you may or may not have experience with this. Redis is actually kind of like a short-term memory, like kind of like what we call a cache memory, and it's basically in memory or in RAM storage. So remember I had said before that hard drive is the long-term storage. RAM is kind of the short-term storage that is whatever the processor is working on. So what Redis is in rather than storing it in the hard drive, it stores it into this memory chip. I don't know what I just did there. Now the advantage of that, or the reason how I'm using it, is in the forgot my password portion. You can fill out your email, and it'll send you an email. And what I'm doing there is I'm sending a special key to that email in a link. And when they click that link, they'll come back to a site or come back to a page within the application that says, hey, we see that you're trying to reset your password. And it compares the keys of the one that was emailed out versus the one that the person's actually trying to log in with. So what Redis is really good at is I only need that key for about 5 minutes, right? When they click forgot password, they should be basically responding to that within 5 to 15 minutes. So it's a nice short-term solution. I want it to dump out of the database after that. Otherwise, I would just have thousands of reset links or reset keys sitting in a database collecting dust because people would never use them. So Redis is a really amazing kind of short-term solution. So I'm using Redis for that. Now, if I was switching this all over to AWS, which I should, we actually get kind of a really cool set of services that take over what Heroku is doing. And then I snuck one extra one in here as well too to kind of talk through. So we're still using S3 for our bucket solution. We're still using React in the front end. But instead of using Heroku, we are using a service called Elastic Beanstalk. Now, Elastic Beanstalk, what that does is a great way to host applications super quickly using AWS. And it's kind of that full spectrum service of all the little bits and pieces you would need to get your application up and running. So when I talked a little bit about processor, RAM, and memory, processor, RAM, and hard drive, Elastic Beanstalk takes care of all of this for you, and then it takes care of the operating system as well too, and it creates and sets up an environment. So if you're like hosting a Node application, it's already got Node installed for you. It was really set up to be kind of that really user developer friendly experience, and so Elastic Beanstalk is the service that you'd use kind of in place of where you're typically used to in Heroku. We've talked about RDS. RDS is the Postgres or SQL solution or relational solution for AWS. And there's that statement can expand. There's actually quite a bit more as you get into things like big data or streaming data. And there are other solutions that are also relational, but just the one that you're probably used to the most is going to be RDS. If you've used Redis, or in the case of, I built a case for Redis earlier, Elasticache for Redis is the solution for Redis in this case. And so that's a separate service I can use through AWS. And this last one I snuck in here because really there's a good solution built into AWS to a big problem that I had with building the Heroku version. So in the application, when I forget my password, I have to use a technology called NodeMailer, and I have to just go through and set up accounts. And it gets into this like, how do you email your users? And they're actually, I suppose SNS is probably not a good example of that, but there are emailing services. I probably picked the wrong one. I'll come back to that in a bit. But NodeMailer's got a lot of security flaws. There's a lot of security considerations, and so there is email messaging through AWS. And as I said that out loud, I realized I made a mistake because this is probably not the right solution. As you need to approve this, but just another messaging service that AWS has. Revisit that here in a second because I do want to talk about SNS and what it's good for. But so once again, kind of what are the quick hits here? S3 is a great service to learn out of the gate. Elastic Beanstalk is a great service to learn out of the gate. RDS is a great service to learn out of the gate. If you're coming from the Mongo world, there's actually two good solutions for that. One is DocumentDB or DynamoDB. And they serve a little bit different functions, and I would encourage you guys will learn about all that when if you guys go down the AWS certification. But obviously AWS has a MongoDB solution as well too. So I think those are kind of like getting your bucket service figured out, getting your Elastic Beanstalk service or your hosting service figured out, and then your database solution of choice figured out. I think are the places I would start first, because those are direct responses to A, the applications that people are typically building, B, the replace the services that you're probably already using through Heroku. Now, there is a strength and advantage, of course, is as you start to use more and more services, it does get easier for them to talk to each other. So the next solution I have is basically a series of solutions stitched together that solve a pretty big problem or problem I wanted to solve. But before I do that, I'm just checking out the comments here. One second. Okay, so Carmina asked the question, Elastic Beanstalk or EC2? I have experience in Lambda. EC2 is a service provided in Elastic Beanstalk. One of the things that AWS does really well is that if you have context and you have experience and you know how all these different pieces work together, it's not hard to stitch together. So a great example would be, I'm literally today had a conversation with one of my senior developers and one of my product managers. And my product manager, he wants a prototype of this IoT solution. And he's like, man, Greengrass it's a new service provided by AWS. Let me go find it here real quick so you guys can see what I'm talking about. Sorry, I got all these Zoom pieces in front of me. Come on. Greengrass. So IoT Greengrass is a collection of services that recently came available. I think back in February. It has not been that long. But it's a collection of services, actually kind of stitched together quite a few different AWS services to kind of be this holistic service and make it easy for to kind of bring this IoT concept together, cloud IoT. And I was like, man, Tim, he's my product manager. I was like, Tim, this is really overkill for what you're trying to do. I think there's like machine learning in here. I think this might be way more than what you want. And so we went with a more home-rolled IoT core solution and QTT, et cetera. So going back to Carmina's original question, is that Elastic Beanstalk is not only EC2, but it's also got things like volume storage and the rest of it figured out, the application side of it figured out. So it's a piece of it. EC2, you could limit, whereas like Elastic Beanstalk is good for like whole node applications. Like if you know you're hosting a node application, it is the go-to or one of the go-tos, especially if you're starting out. And there's lots of caveats to that, like you can get into nuances and whatnot, but just generally speaking, that's a good way to explain it. Yeah, of course. Okay, so I'm gonna bring you up to the Aftercamp website. This is our website, and basically what I built is I built a series, use some AWS services, and what the AWS services do is that this next string is it checks my website every 5 minutes or checks Aftercamp every 5 minutes, and it shoots me an email if the website's down. And so that way I know at any point, now I feel bad because Michael's here. If Heroku is down, which is more often than I care to admit, but I need to get this one on Elastic Beanstalk. I'm actually working on a bigger upgrade, but so I'm using AWS to check my site and send me messages to let me know when my site is down. So let's take a look at the architecture graph for that one here real quick, and kind of a neat one. Try to declutter some of this. My guess is you probably got a million tabs open on your home computer, so we should really work to keep these pared down. All right. So here are essentially 4 services I'm using. Amazon Eventbridge, to AWS Lambda, to check my website, to CloudWatch, to Amazon SNS or Simple Notification Service. So I want to talk briefly about what each of these are. And I have to start off with Eventbridge. And I think they recently renamed it, I think within the past 6 to 8 months. I think it was called something to the effect of like Cloud Events or CloudWatch Events. So the Eventbridge moniker is relatively new. But what this does is that you are able to trigger events. And really what this is it's a triggering system that makes events happen. And to understand what that means, like typically when you think about development or you are graduating from a boot camp, you're approaching development from the standpoint of a user. And so the user initiates all of the events. Like they click the button, they submit the form, they log in, they whatever. But in this case of like, I just want to check to see if my website is up every 5 minutes, and then for it to email me if I, there you go. Michael left some notes on the EC2 instance stuff in the chat. If you need to trigger something that's an event, in this case, to check a website, to send an email to the owner, that's not user driven, right? So you may have heard of something like a cron job, which is a type of application you can build that would run over a period of time. And so you would write like maybe a little like node cron job and host it on a server. And it'd be essentially a service that checks something periodically, run some code if during that periodic event, and then you can respond to it. So once again, it's not user driven, but it's time driven. So rather than me go through the whole hassle of programming all of that, hosting it, and seeing if that thing is up, I get to use Eventbridge instead. So Eventbridge, let's see, that's SNS. Here we go. Eventbridge, I set up an event called Canary, a canary in the coal mine, to run every 5 minutes. And I use this to basically trigger what's called a Lambda. Now, Lambda I know is typically when people have heard of AWS, they hear like AWS Lambda. Lambda is a super cool service from AWS, probably one of my favorites. And so what's happening is the Eventbridge trigger that's running every 5 minutes runs a little snippet of code that I wrote in Python called Lambda Canary here. And basically what it does is it checks to see if a website is up and running. So it does this little request, and it goes to the site and basically just says, is it failing or is it passing? And so it goes off to the site, checks it, and if it's failing, we actually have another service called CloudWatch that basically listens for failing events on that Lambda. So if the event fails, then syncs up with another service. So this is the watcher, right? So here, let's go back a second. Eventbridge triggers an event. Lambda is the event. It's like now the event is triggered. This is the event. In this case, this event is checking the website. CloudWatch is watching for specifics of event. In this case, it's looking for a failure that I wrote in the Lambda that says, hey, I'm looking for this specific situation. If the failure happens, we want to go ahead and send a message through SNS, or simple notification service. And so it's going to publish a topic that says, hey, we call this the pub sub model. We're publishing a topic that says, hey, this thing has failed, and we want Scott at Aftercamp.io to know about it. So we broadcast an event that happens, and we have one subscriber that's listening for it. And that basically when it noticed something in this pub sub queue, we basically say, hey, we're gonna go ahead and send an email. Now, really quick, just taking a step back, when we think about architectures and we think about basically like what we're accustomed to building when we graduate from boot camp, we typically operate pretty transactional through REST, right? You do a get, post, put, delete. And so we're very accustomed to client makes a request, server responds, or server makes a request to a service responds to the server. It's very transactional and typically user driven. Pub sub or publish subscribe is a little bit of a one that you might not be familiar with, but essentially we have a queue of messages, and then we have like it's basically a queue of publications, and then a subscriber listing for those publications, and then we can respond to them. In this case, we're responding with an email to Scott at Aftercamp.io, just says, hey, the server is down, and then I get to hop on in the middle of the night and figure out why. So here, like I said, it's a collection of 4 different services, and you can kind of think of this different. So let's take this a slightly different direction. Eventbridge, let's go back to our graph here. What's that one? Come on. Eventbridge, let's say, fires every 30 minutes. And I could write a Lambda that, let's say, is connected to Twitter. And I have a database of random tweets. And so basically what we could do is you could set up another, so the Lambda reaches in and grabs a random tweet and then tweets that through an account. Now that's kind of the end of it, right? Like I don't need to like have a CloudWatch or a simple notification system. But the point here is that we can take these pieces. You don't have to use Eventbridge to like listen for like a website working. You can use it for a lot of things. In this case, I'm using it for a health check. So I'm gonna go back to a very fundamental concept I kind of work with most of my students is that all the pieces of programming are simply tools. What you build with the tools is up to you, right? So like, you learn that a saw cuts wood, a hammer hammers nails, but like you can build a doghouse, you can build a birdhouse, you can build a house, you can build a deck, you can build any number of different things with those tools and the resources that you have. And so what's cool about AWS, and that's kind of the whole point of this, is that AWS has all these different tools that do these different things. And with those tools, you get to kind of pick what you build with it. So in this case, I'm checking to make sure my website's up.
Scott, question for you.
Go for it.
Sort of a real world scenario. Let's say I'm an e-commerce shop owner and I have all my products in a database and I want to know if someone else is selling my product, same products I'm selling, but at a cheaper price. Is this kind of what you would use to do that? The event
Yeah, I mean, you could do that. You could do like set up a daily Eventbridge to the Lambda. Basically, is a Python web scraper. You have to go scrape the other websites to pull the data there. So it'd be a pretty big Lambda, but you could totally, it's reasonable to do that, because if like, honestly, all Lambda really is that it's a deployed service. So it doesn't have like a user, like you're not interfacing with like a front end at all. But Lambdas can operate as services that you would normally write to do some of these processes. So yeah, hypothetically, for sure. You could have it scrape it every single day and send it to, you could actually send a listen, CloudWatch could listen to see if array value is greater than 1, the prices that are cheaper than yours. And then you could send yourself an email automated report on being like, hey, here's all the websites and here are all the products that are selling cheaper than yours based off of the Lambda. Crazy powerful. Yeah, no, that's super cool. Okay, let's talk about what's next. I really wanted to just talk about, like we're kind of getting to the top of the hour here. I make sure to just wrap up with being like, here's where you go. So what's cool about AWS is they have a really cool certification path. And I will tell you that like, to be clear, like I think it is possible to get a job as a developer but it is always cool to see it, meaning that as a hiring manager, when I'm talking to devs, what's that? Am I back? Okay, cool. So the certification is like, if you have it, it's super cool to see. It actually tells me that you understand kind of these architecture and IT ideas, because like the joke that me and my architect had this today was like look, like building the applications half the struggle, getting it out into the world is the other half, and getting it out and deployed or coming up with creative solutions to problems with tools like this is like the other half of the job. And typically it's reserved for like senior developers or architects, but you can get on that right now. And like I said earlier, like don't let your employer dictate the growth of your career, because they'll just grow you in the direction that they think you're capable of. So I love this certification track. I need to do a better job. I've been studying like crazy and I've just not taken the tests, so I need to. But you study, you take tests, you can earn these certifications. Actually, where you start is right here. They recently lifted this idea that you had to like go through a path, and so you can actually just hop right into like an associate developer certification if you want. But what I will say is I do think there's a ton of value in starting with cloud practitioner and working your way up. So go after cloud practitioner first, and I think that's a really good start. And then you can kind of work your way up to the associate level certifications and the professional level certifications, and then you can get into specialties as well too. And every time I see this as a hiring manager, I'm just like, I know this person gets this other half of things that I'm talking about. Like they get how services talk to each other. They get that things are event driven. They get that, deployments, all this stuff. So can't say enough good things about seeing these certifications as a hiring developer. I don't have them myself. I've been doing this for 15 years. So like don't stress it, but like it definitely is like a good little like stamp on your resume for sure. They have a website. So AWS has training paths for all of the certifications. So in this case, we're looking at the Cloud Practitioner Essentials. And they got a full course. And I actually, I think I did it as they were transitioning, because I went through a course and then I saw they launched this one. And I was like, oh man, I'm going to go retake it all. So I went through and like retook all of this stuff. But it goes through and like teaches you a ton of different services, breaks down all the different like offerings that AWS has. But it also gets into things like costs. It gets into concepts like I didn't really get into like scalable solutions, like a huge part of this, auto scaling, security, like edge serving, meaning like you're serving content from physical servers close to the user. It covers so much, and there's so much to know. And they do a really, really good job of breaking it down and making you kind of taking you along for that ride. But like I said, I think the big piece of what I wanted for you tonight was just understanding that each of the services, of the many services that they offer, solve some problem that you might have. And they can be big or small, meaning that you can look at something like Elastic Beanstalk to do like a full application deployment. You could look at Greengrass for an entire IoT machine learning solution, or you can kind of just get down to those individual services as well too. But here's a list of all of the services, and it's quite extensive. And I'll tell you right now, the goal is not to learn them all. You will drive yourself insane if you try to do that. But really, like zoning in and finding the few that like really help your workflow is a good place to start. And you'll start to branch out, and you'll start to you can go to like the reInvent as a conference they host every year. You can learn about what's new. But I think that the certification tracks and the training that they have is a good way to like ease into kind of like the holistic picture that you might need or you might want. So that's it for the presentation. We're about 3 minutes at the top of the hour. I'll stop again for questions as we wrap up and just check to see what we have existing. But yeah, I can't say enough good things. I love AWS. And I'm so happy that you came tonight. I'll stop sharing my screen too so I can see all your pretty faces. For sure, you, James. I miss you, buddy. All right.
Same here.
Yeah, dude. Hey, there you go. Michael's got a blog post on some of the cool, a couple plugs there. So blog posts on some of the services, some of the core services. Love it. We will definitely share that out in the Slack group too, Michael.
I have a kind of, this is meant to be a high level question.
Yeah, dude.
And it's something I've wondered ever since I learned about the concept of cloud computing. Like, so my computer has all of these, my MacBook has all of these computery things inside of it, the RAM and the processor and the hard drive. Why is my computer not just like an empty shell that talks to the cloud and serves me only what I need? Like,
getting there.
If I only need a tiny computer, it does that. We're getting there.
I think we're getting there. I really do. I talk about this a lot. So it's like, I want to paint the vision of the future, like just like some Black Mirror stuff here. I believe that there's like this. So cloud computing, like it was something I actually first really like, it hit home for me big time when Google announced Stadia. And what Stadia was supposed to be was like the video game console killer. And the idea was that it worked a little bit like a Chromecast, where all the computing happened in the cloud and just beamed down through the Stadia, and like you were playing it that way. I'm like, it doesn't seem like it's going to be that good, but it like had like a lukewarm reaction to when it entered the market, and I think it's still kicking. But Google has a tendency to kill things off pretty quick, so I don't know how much long of a shelf life Stadia has. But it brought up a really interesting point of what you just said, of like, how long is it before we just buy a monitor and like that monitor is cloud connected and all the processing, and you don't upgrade your hardware every couple of years. You just like just like EC2 or with AWS, you can actually pick the levels of processor, pick the level of RAM, and you just like lease out a partition of computer that you need. And the reason why I think there's going to be a huge driving factor of that is that there is like, I don't want to be like crazy, but there's like a secret race, I feel like, to get computing into your glasses. And so Google's working on it, Facebook is working on it. This is all like under the VR flag, but mixed reality is like the kind of the intersectionality between VR and AR. So AR is obviously like through the phone, you have a camera. But what I think is happening, especially with when you look at things like the Microsoft HoloLens, which is a really cool device, it's 3D overlays interacting with the real world via sensor. and I'm just waiting for them to get the hardware out of the crown that you put on and into the cloud. So basically, I think at that point, we can get down to form factor. And once we get down to form factor, I think you'll see consumer adoption. But until we get down to form factor, like they look ridiculous right now, like these big things that you wear, like it's crazy. Which PS opens up like this whole other crazy world of cybersecurity concerns. So if you've ever met me, you know that my core disciplines are cybersecurity, game tech, and web tech. And so like I'm just waiting for all of it to converge together and be like, oh, it's crazy. Yeah, thanks for plugging your content too, Michael. That's awesome, man. We'll make sure that it gets out of this meetup and into the Slack channel too, and shared with everybody.
I do have a question.
Yeah, man.
So the AWS certification, that's just so that you're proficient in the use of AWS, but not necessarily like for getting a job with AWS.
Yeah, I think that it can go either way. So I think a couple thoughts on that. Like if you go after a cloud engineer position or a DevOps position, they might actually require you to have certifications. And so Azure's got them, GCP's got them, AWS has got them. Like if you're going after like a DevOps or cloud engineer, you're like most certainly going to have it. But what I guess my point is the thing I want to underscore is if you're a developer and you have that, it just ticks so many boxes of things that I believe that you would have some fundamental understanding of, and mostly the interaction between services, servers, and front ends. Because when we work with associate level developers or junior developers, they have a harder time seeing the bigger picture and how it all fits together. And the AWS is kind of that, right? It's a network of things in a system that all work together to accomplish some tasks. So
Right.
I really do feel like AWS can be an indicator that there's a lot going on up there, which is good.
Okay, cool. Thanks.
So you think even if somebody wants to be a front-end developer, that there's value in having at least that cloud practitioner certification? Is that what you're saying?
I think so, yeah. And I'm gonna go back to
Good to
this, when I work with, I've worked front end, back end, full stack, architecture. Whenever I work with team members that just know what I'm doing, it elevates the conversation, right? So this one project I did for Google, I was kind of this intermediary, I was sitting in the middle between the front end developer and the back end developer, and I was helping them talk. And so I was writing the code in between, but like it was nice for me to know what the front end developer's concerns were, and like the back end developer who didn't understand the front end and the front end it was nice to be the intermediary. So I will always say, if you learned full stack in boot camp or through college or whatever, it only benefits you if you end up specializing and knowing what the other side is doing. And so, yeah, I can't say that enough. Yes, it's cool to hyper specialize. Like, you want to be a React developer, awesome. But if you know what your .NET developers' concerns are, they're gonna love you, or Django or whatever. And if you understand kind of at a high level too of like what your front end interaction does to the back end, and like once again we built that crazy system where it was 5 node servers talking to one database, like just even understand like, okay, I know how my data is progressing through the system. It really helps kind of think more holistically. And actually, small plug for the next meetup, which I should have done before everyone left, is that we're covering ERDs, open API documentation, and architectural graphs in the next session. So we get into this conversation about data modeling and really documenting our projects. And once again, I think front end developers, if they have that experience, it's so great. Because I think most of the time when you learning code, and I'm talking about just pattern behavior of new developers, they have a tendency to think out their application really from the front end only, and then they kind of work the back end based off their vision for the front end, where it's like way better to actually think the other way around, where you think about the data first, and then you work your way into the way the front end's going to look. And so very simple concept. This is like so classic textbook screw up, and I've been doing this for 15 years. On the Aftercamp website, there is the place for you to enter your email to receive future notifications that we're working on. Like a dummy, I forgot to collect the date of when people actually filled that out. So I have a whole huge database of when people signing up. I have their emails and names, so I have no idea when they signed up. So I'm like, well, if I was thinking data first, I would have like totally addressed that problem, even though the front end, that's not reflected at all, right? It's not a concern because we're just asking name and email. But that's kind of that classic case of like, if you think data first, it really will inform. And so, yeah, I mean, if you're like, I prefer front end, like I prefer React and Unity and Unreal and all those things. But it is super helpful to have a data first mindset and then kind of work your way into the front end. Long way of saying yes. Draft, yeah, draft. No, don't do that. All right. Thank you all so much. I'm gonna go take my kid to McDonald's. Have a great night, and I will see you guys again in a month. Thanks, everyone.